Students often suggest either that a firm increase price when profits are low or negative, or increase sales when profits are low or negative. Well, do profits always increase when the firm increases price? Do profits always increase when the firm increases sales? To examine this issue, let's work with a simplified example and look at what happens when the firm increases its price. Suppose that a firm sells pizzas and charges a uniform price for all units sold. Let's say that the current price is $10. Also assume that the current unit sales is 1,000 pizzas and that total cost is $10,100. The price and quantity information tells us that total revenue, which is the product of price times quantity, which will be, in this case, be $10 times 1,000, must be $10,000. This means that profit must be minus 100. Profit is simply your total revenue less your total cost. In our example, it's going to be 1,0,0,0 minus 1,0,100. So here we have a situation where the firm is suffering an economic, or is earning a negative profit. It's suffering a loss. Now suppose that an employee with an MBA from University of Richmond suggests that increasing price from $10 to $11 would push the firm's profit out of negative into positive. To prove the point, he produces the following table. It shows price going up from 10 to 11. As a consequence, total revenue is going from 10,000 to 11,000, and profit is going from minus 100 to 900. I would hope that an employee with an MBA from VCU would point out that the suggestion is naive. The suggestion assumes that the increase in price would not affect the quantity sold. However, the law of demand says that when you increase price, that's going to lead to a decrease in the quantity demanded, and assuming the firm is selling what the amount consumers want to purchase, a decrease in the quantity sold, and a decrease in the quantity sold. This table fails to reflect the decrease in sales that would occur. Suppose that we have learned that a 1% increase in price leads to a 1.5% decrease in quantity. If we use $10 as a base, that means the percentage change in price is 10%. Percentage change in quantity is the change in percentage change in price is the change in price over price. So we're going to have a price went from 10 to 11. That's an increase. Price went up by 1. The base was 10. That equals 0.1, which is the same as 10%. Percentage change in quantity. Well, let's stop there. If each 1% increase in price makes quantity fall by 1.5%, that means that our quantity is going to fall by 15%. That's 10% times 1.5. What's 15% of 1,000? Well, that's 0.15 times 1,000, which is equal to 150. This 10% increase in price is going to reduce quantity by 150. If we subtract 150 from our initial value of 1,000, we now get a new quantity of $850. If we multiply price and quantity together, P times Q, that means that our new total revenue is going to equal 9,350. Well, that sounds pretty bad. Total revenue's fallen. Before we can conclude, though, what happens to profit, we've also got to figure out what's going to happen to total cost. As you decrease your output from 1,000 to 850, you're going to be able to reduce the amount of inputs that you employ. Therefore, your variable and total costs are going to go down. Well, marginal cost is $6. That tells me, an assumption, we're going to assume that marginal cost is equal to $6, and that value is constant over the relevant range. Marginal cost measures how much extra cost the firm must pay for each extra unit it produces. It also shows how much total cost will fall for each extra unit the firm reduces output. So if I cut back my output by 150, and the marginal cost of each unit is 6, that means that my cost is going to change by $900. Since I'm reducing output by 150, my total cost is going to fall by 900, which means the new total cost is going to be 9,200. 10,100 minus 900 gives me $9,200. And now I want to subtract total revenue, or total cost from total revenue. The new profit's going to equal 150 bucks. Well, sure enough, the suggestion that an increase in price will pull profit out of the red is correct, but the increase in profit is much lower in this more complete analysis than the naive example presented earlier. Well, now suppose that a 1% increase in price makes quantity fall by 4% instead of the 1.5% we assumed earlier. We're still increasing price by 10%, but now the quantity is going to fall by 40% instead of 15%. Get rid of that. There you go. It's going to fall by 40%. 4 times 10 gives me 40. 40% of 1,000 is 400, so the new quantity is going to be 600. When I multiply 11 times 600, I get the new total revenue is $6,600. But I have reduced output by 400. 400 times times marginal cost of 6 means my total cost is going to fall by $2,400. Subtracting 2,400 from 10,100, we get the new total cost is $7,700. Subtracting total cost from total revenue gives me a new profit of minus 1,100. Yikes! Profit, the loss increased from 100 and got bigger, 1,100. This analysis shows that the impact of a change in price depends crucially on how responsive consumers are to the change. This lesson examines how to measure the responsiveness of consumers and how to use that information to set price.